Today, I'm going to be doing some research into entity component systems. I don't know if that's really what I should be doing. Let's see if I can reproduce something that I want to demonstrate. We're going to have 3 guys doing pathfinding on us with A star. So here's one example. Ideally, these guys would kind of box me in. Not necessarily on left and right side, but at least right now on my right side. And then if I move to my right, on my left side. Now, the reason that they don't do that is because the position update order of the entities is independent of the position of the entities on the map. And so if instead we sorted the entities when it came time to update their positions, we could allow the entities closest to me to move first, and that would free up their space so that other entities could move in closer. For example, if the bottommost guy is actually moving first, when I move back and forth, he wants to close the distance by coming closer to me, but both tiles are already occupied, and so he doesn't get to move. And so one thing we might want to do is sort the enemies by their proximity to the player, and then have them take their turns based in that order. Things get a little more complicated when the enemies have properties like speed and whatnot, when they're not all the same speed. Another issue is that for the number of enemies that we have, we are basically loading the same asset, because it's the same enemy. We're loading it 3 times and storing it once on each entity. And so is there a way that we can import shared assets only once and then refer to them by an index or something like that? I could just go in without any research, go in blind and try and code up a solution myself, but it jogged my memory and made me remember this entity component system, ECS, so-called thing. Maybe ECS helps with this, maybe it doesn't. I have no idea. So the very first thing we're going to do is just figure out what an ECS is. It's going to ask Grok. So what is an entity component system? An ECS is a software architectural pattern primarily used in video game development, but also applicable in simulations, robotics, and other domains requiring flexible, scalable object management. It structures a program by separating data, or components, from behavior, or systems, with entities serving as lightweight containers. Oh, interesting. Entity component system. I thought it was an entity component space, like entity minus component space system, a system for entity and components. Okay, wait, so this is like a Triforce, like a model view controller. Entities are simple identifiers, often just an ID or an integer, representing game objects, a player character, an enemy, or a projectile. Entities hold no data or logic themselves. They are composed by attaching components. They hold no data or logic themselves. Interesting. I would expect they at least hold data. A component, a pure data structure containing properties or state. Okay, so this is where the data is. Example, positions, velocities, health. Systems are logic processors that operate on entities matching specific component combinations. Example, movement systems, they update position based on velocity for all relevant entities. Render system draws entities with position and sprite components. All right, so it looks like we have a pose, a translation and rotation, and then we have a transform local to world, and then we have a render. These are components. So this is state, this is data. I'm assuming, well, I don't know what any of this stuff is. I don't know what well, here's the system. Okay, yeah, so this is an algorithm that will take a pose and it will perform some computation on these things. And then we can store the result, apparently, back in a component. And each entity is just an ID or a reference or a pointer, perhaps, to some state. Component, so this might be position, for example. But there's a thing called an AOS or an SOA, right? An array of structs or a struct of arrays. It could be possible that this is an SOA right here, right? We have a single struct and it's got an array of data of type 1, an array of data of type 2, an array of data of type 3, and then entities would be indices into the array. I don't know if I'm reading too much into this right now. I'm just kind of speculating. Comparisons with traditional OOP. ECS emerged as an alternative to classic object-oriented programming inheritance models, which often led to issues in complex games. Okay, so it's basically inheritance versus composition. Structure, flat, entities, aggregate components, systems process data. Okay, so kind of like what we saw up here, right? An entity aggregates a collection of properties. Flexibility, you can add or remove components at runtime for new behavior. Right, a component is just a collection of data, and in this case, the entity indexes into some collection. Performance is exactly what I was saying, right? Structures of arrays. So components are stored contiguously as a structure of arrays, improving CPU cache usage and enabling parallelism. ECS is data-oriented, focusing on efficient memory layout and bulk processing. Yeah, while OOP is control flow-oriented. That's a good way to describe it. It's totally true. Control flow oriented. By the way, I'll interrupt our research here and say that I've read in many cases by many experienced game developers that a lot of games don't even need an ECS. I'm not sold on the idea that I need it yet. Overhead for simple projects. Okay, exactly as I was saying. For small games with few objects, traditional OOP may be simpler, so we might not even need an ECS. I'm not using OOP though. I'm already using composition, basically by nature of Jai. Examples in practice. Consider a game with players, enemies, and bullets. Composition, position, velocity, health, renderable, aka sprite data. Okay, so this would be a pointer. In my case, this would be a pointer to an SDL texture. Games like Overwatch and various Unity titles use ECS principles for netcode and scalability. Dude, like this needs qualification. We didn't learn anything about netcode relationship with ECS, but okay. Maybe it means to serialize entity state or something and send it over the network. I don't know. We'll give Grok a like. You get a like. I want to look at something else I have here. I found this in the Jai Discord maybe 1 or 2 weeks ago. This is an entity component system written in Jai by Sir Roey B1. And me not knowing anything about ECS except for what I just read, I kind of want to see what an implementation looks like. Network synchronization. Okay, so there is some relationship to the so-called netcode. It became apparent that outside of the rendering code, the ECS soon became the largest part of the code base, okay? The complexity of managing the ECS vastly outweighed the benefits of having such a dynamic system. I wanted to try to find a solution which had some of the organizational benefits of an ECS while keeping gameplay iteration times fast and code complexity low. I totally agree with this. Thinking along those lines, some of the things I missed from non-ECS frameworks were being able to easily inspect the entire state of any entity in the debugger at any time. That is, yeah, that's going to be tricky, right? If we remember from Grok here, we might have a struct of arrays, so all these arrays, and then entity is just going to be an index or something. So when you're in a debugger, you'd have to say, you know, my struct dot component one dereference at 0 or 1 or whatever. Also, another thing I just realized is, I mean, here we don't have data. Is each element here like a pair implemented as a struct that has data of some select type for the component, and then also bool or something like that, indicating it's available or not? I don't know. So component data is spread through memory and accessed by index. Okay, we're on the right track. Thus can't be easily reconstructed in a debugger. Exactly. An entity's type is defined by the set of components it owns. Exactly right. So essentially you can think of it like composition, except we're not composing this as properties of a struct, that's like an entity, or of members on a class or anything like that. It's just a collection of what is resolving here when you ask for entity with ID 0 across all these components. All components of the same type in an ECS want to be treated in the same way in all cases, but that isn't always correct or convenient. Then that brings the other issue of what is a player if not defined by some concrete type. Exactly. So is a player just an entity, or does a player have some additional type distinction to it? This tends to create a lot of duplicated component types, which only differ by name. Yep, I feel you, man. Right here, I call entity render on the player, and then I call the same entity render on individual enemies. But if we look at what's actually happening, I think right now these two routines are actually the exact same. The reason I separated these is because in the case that that player and that enemy have different properties on them in the future, I've got this available. I had no idea how it was going to turn out, so I just kept it separate. An entity is a type, a position, and a tile set, and a player right here is an entity, has a type, has facing and move cooldown, and an enemy has the exact same thing. So they're actually basically the exact same type, with the exception that the names and therefore the types in the type system are distinct. The base entity class in my engine is a very lightweight struct, which contains data that all entities should have: a name, an ID, entity flags, and a position. I'm following the same thing in Spirit. A specialized entity type may look something like this: insert, run, as base entity. It inherits from base entity type. I don't know why you can't just do this. I would assume you could just do that, but maybe there's something about Jai I don't fully understand yet. I think I'm actually just going to try and whip up a minimal ECS by myself. I'm going to have to go to sleep tonight and think about how much work it is to just implement kind of a vanilla ECS without this kind of dynamism and reflection and whatnot. I don't really feel the need for reflection in my particular designs. They're not that complicated. Sparse storage is not yet implemented, but what's the idea? Something that doesn't immediately seem possible is the ability to optionally add some data to some entities in a type, but not to all. There's a couple ways this can be solved. The first, most trivial solution is to put the optional data on the entity struct and add a flag to indicate if the entity has the data or not. Okay, right. I was talking about this in the Grok situation, which is like, how do we represent missing values here? Ability ability to optionally add some data to some entities in a type, but not all. So here, the entity is more than just an identifier. The entity is a struct, the player is a struct, and it has various fields on it, and one of them is mount info, and we say that it has mount. All right, well, this was a kind of a short exploration here, but I'm just picking two really small data points, one being Grok and then one being the implementation of this simple entity system, which I guess would not be a vanilla entity system, but it did outline some of the things that we read about. We can do that right now, just a little bit more research, and then I think at the end of the day, we just got to implement this thing ourselves. The ECS is a data-oriented software architecture pattern primarily employed in video game development and real-time simulations. Okay, so this is actually similar to what Grok said because, no surprise, Grok generated Grokopedia. I don't fully understand what a system is. Like, I guess a system is just a function, right? It just takes in an entity and takes in some components and it does some stuff with them. Historical developments, no, we're fine. Key milestones and influences, no. While ECS excels in large-scale, data-intensive applications, OOP may be preferable for smaller projects featuring complex entity-specific state machines where tight encapsulation of behavior specifies development without the overhead of system orchestration. Yeah, I think that's the trade-off that we're going to be making, essentially, is how much ECS do we want? We don't have the option of object-oriented programming in Jai, which I'm fine with, but the question is basically how heavy do we want the ECS to be? I really should just put finger to keyboard and hack around with this and get a feel for how much mileage we're going to get out of that idea. Due to an ambiguity in the English language, an interpretation of the name is that an ECS is a system comprising entities and components. This is like what I was saying earlier, so I apparently fell for the trick. Entity IDs can be used when communicating over a network to uniquely identify the entity. Okay, so now we get a little bit example of what that netcode thing is all about. Some of these advantages can also be achieved using smart pointers. No thanks. Maybe I'll create a new branch in the repository and we will experiment with a very simple entity component system and we'll decide for ourselves based on some practical experience whether or not that is a system that we want to keep and proceed with, or whether this right here is enough. Because right now this is serving us pretty well. Thanks for tuning in and we'll see you next time.